So let's take some examples on the calculation for the solubility of a solution. The formula for calculating solubility is represented as the mass of solutes multiplied by the molar mass of the solute times 1000 cm cube over the volume of the given solvent. So mass of the solute over molar mass of the solute times 1000 cm cube all over the volume of the given solvent. Use of it. Example 1. So assuming the solute used in an experiment to be potassium triisonitrate 5, and then the mass of the saturated solution was found to be 55.27 gram, while the mass of the evaporated solvent is 43.40 gram. So we're expected to find the solubility of potassium triisonitrate 5 crystals. So notice that you weren't given the mass of the solute. You're just given the mass of the total solution. So to be able to address this question, you first of all have to determine the mass of the solutes. So you do that by using the parameters that are given. So the solvent is water, while the solute is potassium triisonitrate 5. And the mass of the saturated solution is 55.27. Mass of the solvent is 53.40. So to find the mass of the solute, which is the dry residual gas after the evaporation of the solvent, you just have to subtract the solvent that evaporated from the solution, total amount of the solution, and you get the mass of the solute, which is 11.87 gram. So with the mass of the solute, you can just simply the formula, we say mass of the solute over the molar mass of the solute times 1000 cm cube over the volume. If you plot it straight away, you get your answer, which is 2.7. But we're going to take a different route so that you see exactly the steps we've taken to get to this place. So here, we try to break down the steps. We've gotten the mass of the solute in the previous slide. Now we want to know the amount of solute that will dissolve in the given volume of water. Okay, the amount of solute that will dissolve in a given volume of water. So mass of the dissolved solute all over the molar mass, that's the formula. So the mass of dissolved solute, as we've seen, is 11.87. When you divide it with the molar mass, which is the given data 101, you get 0.118 moles. So invariably, it means that the 4.34 cm cube of water will saturate 0.118 moles of potassium triisonitrate. But solubility is all about finding the solubility of the solute in 1 dm cube of the solvent. So to get the amount of solute that will saturate in 1 dm cube of the solvent, you just have to cross multiply. So you multiply 1000 by 0.1108 divided by 3.4. So that's what you see below here, but I think that add it immediately. So when you do that, you get your answer. It's 2.7 moles per dm cube. That's the solubility of potassium triisonitrate 5 in the solution. So that's the answer. Now let's get to another example. So don't mind that one, don't mind these ones, just a simple mistake from the PowerPoint slide. Let's say 9.8 gram of solid potassium chlorate were added to 40 cm of water and heated to dissolve all the solid. As the solution cooled, crystals of potassium chlorate started forming. So the solubility of potassium chlorate at 66 degrees centigrade is what? So it's also giving the molar mass as usual. So we're given the mass of the solute that dissolved, and it's 9.8 gram. We're given the volume of the solvent, which is water, and it's 40 cm. So we're given the molar mass of the solute, which is 122.5. So if you plot the graph, I think it's mass of the solute over the molar mass times 1000 over the volume. So when you plot it inside the graph, it says 9.8 all over 122.5 times 1000. The volume of water given is 40. So you do the maths, and when you do, you realize that the answer is 2 moles per dm cube. So the solubility of potassium chlorate is at the temperature given is 2 moles per dm cube. It's a simple way of solving it. So you bear in mind of the parameters given. That will help you to plot in the formula and then solve it. The next one is calculating the solubility product. It is, as the name implies, it's just finding the product of the solubility of the solutes in the reaction. So examples. So you're asked to determine the solubility product of silver bromide, and the molar solubility given is 5.71 times 10 raised to the power minus 7 for silver bromide. So the first step you take is to dissolve the silver bromide, to disassociate it into different elements, separate elements. So when you do that, you get silver and you get bromide. And then the ratio of silver to bromide in the equation is 1:1. 1:1. So some elements will have 2:3 or 1:6 and the like. So this ratio is very vital, because with this ratio you can multiply, you apply it to the solubility product formula, and then you get your answer. So here we have 1:1, and it means that 5.71 times 10 raised to the power minus 7 of silver bromide dissolves to give you the same amount of silver and also the same amount of bromide in the solution. I think it goes with law of conservation of mass, or something of that nature. So when you put in the values in the solubility expression, you get 5.71 times 10 raised to the power minus 7 multiplied by 5.71 times 10 raised to the power minus 7, and you get your answer. But assuming the ratio is 2:3, what you do is you first of all multiply the silver bromide, the moles given for silver bromide, by 2, and then you multiply this one by 3. That's if the ratio is 2:3. And when you do that, first of all, before you multiply the two elements together to get your answer. So that's how to solve solubility product. You get to see 2 or 3 questions on that from the past questions, and then you'll be able to do that comfortably well. So another example on that is a saturated solution of silver chloride was found to have a concentration of 1.30 times 10 raised to the power minus 5 per dm cube. So the solubility product is, as usual, you dissolve the elements, silver chloride, and you get silver and you get chloride, and the ratio is 1:1 also. So you just apply the formula we used before. You multiply the silver, that of the chloride, and then you get your answer. Okay, so that's pretty simple. Finally, don't mind this, just a recap. So bear in mind the formula for finding solubility. It's the mass of the solute over the molar mass That's molar mass. Can't write well with these. Times 1000 over the volume. So always remember that. And if any parameter is not given, you first of all find a parameter before you can be able to solve the problem. And that of solubility product is, I think it's KSP, or it's the symbol for solubility product. It's not important anyway, just know what you're expected to do. Then it's just for you to multiply between the two given elements. Okay, and if any of them is raised to power anything, you just multiply it before you do the final multiplication. So that's it for calculation. When you get to the past questions, you see a number of them, you'll be able to do them pretty well. I think more than 50% of the questions on solubility focus on these calculations. I wish you good luck. Thank you. Bye.